Hello friends, welcome back to the bench. We have another board for AM5 socket replacement. This is Asus, another B650. This is B650 Plus Tough Gaming. Very nice board. Actually, what's interesting about this board, take a look at this. The size of the coils is well, they're much bigger than I'm used to. Typically, coils are a little bit bigger than this one. This is probably SA or IO voltage, and we have V core over here. But another interesting thing is these coils do not have capacitors on the output like these. And this is the first board I see that doesn't have capacitors here. Now there's some plenty of ceramics over here, so maybe they're replacing these. Hard to say, but that's definitely unusual. Now it also has dedicated drivers. I see that more and more nowadays on the newer boards. I assume that's cheaper to manufacture because you only have one chip instead of 2 or 3 transistors per each coil, plus the driver, right? So yeah, it reduces the number of components. But other than that, the board is very nice. Actually, the size of the coils is kind of weird because we only have one full connector and half of the connector for V-core, right? So typically on boards that have big coils and big heat sinks and stuff, we see 2 of these. 2 or two 8-pin connectors and 1 4-pin connector, or 2 8-pin connectors. But here we only have 4-pin and 8-pin, so that's kind of unusual. Now, as far as the board, the IOs, not much. 2 USB-C. We have dedicated USB slot for the BIOS reflash and the BIOS reflash button. There is no optical output, but we have built-in Wi-Fi, and we have HDMI and DisplayPort for the display adapter. But the subject of this video is actually aligning the socket, and I figured I'll just give you a quick tip on alignment because that is something that I personally struggled with the most, and my initial failures were not even around soldering, although that was the main issue as well. But even if I got good soldering, I got good temperature, and the socket sat, dropped correctly, it was misaligned. On some boards, like the previous one that we had, the outline of the socket was perfect, meaning it would match the socket exactly, every shape, right? Because we have quite a few notches here and there. We have 2 notches here, 1 here, 1 here, 1 here, 1 here, and 1 here, all right, with the little loop. But this one, as you can see, we only have a big square, a pin 1 or the little triangle over here to identify the top left corner, and only the outline of this one little notch over here. So that makes it a little bit more challenging to align it. This right side is not going to be aligned with the socket, it's going to be aligned with those little notches here, right? So that makes it a little more challenging. If the outline is exactly like the socket, you have multiple points where you can reference the alignment. With this kind of socket, it's a little more challenging, but the same rule applies as everything. Is first catch it on this little notch over here, right? Then make it parallel, like so, and get a good light and shine it from each side, right? Each corner. I can see that it should go a little bit to the left, but before I move it to the left, let's catch it on this side. No, it's good, right? It looked like it should go to the left. Now it looks like it needs to go up a little, but again, let's shine it on this side. Yeah, it needs to go up a little bit. All right, some kind of tool is better to do it than the finger, but this is basically the idea. Yeah, so now it should be aligned. Let's see the notch. And pretty much it. Yeah, that is pretty much aligned. So that's basically the procedure of aligning it, but you do need Flux to resolder the socket. I mean, technically you could try without Flux, and I've had some success doing it without Flux, but it's inconsistent. Yeah, it will work on some boards it will not. It probably also depends how you cleaned the socket after, how you clean the pads over here after removing the socket. These are shiny, and probably without solder it would work, maybe. But you're gonna have to use solder. The solder, obviously you're gonna use solder, but the socket comes pre-bolt. But you're gonna have to use Flux. So now, what I do is I use a brush, right? I put a little bit of spots of Flux, then I brush it to make it uniform. Then I did the same on the socket. Put a few spots here and there, and then in both directions just spread it nicely. All right. Now, if you put too much Flux, that's not a big deal, but important thing is that if you do it on the cold board, like I'm doing it right now, right, and you aligned it on the cold board, as you start preheating the board, the Flux is going to start flowing, and your socket might move. So the better way is to, obviously you can align it when it's cold, but you check the alignment after the board is preheated, which is a little bit more challenging because the board is hot. It's going to be roughly around 100 degrees, so it's not like you can put your fingers here because you're going to burn. So that makes it a little more challenging. Plus you're just kind of leaning over it. All that heat is going into your face, and not to mention all the vapors from the Flux and stuff. So be as quick as you can when aligning the socket. The other thing I forgot to mention, because we have the notch over here, but sometimes even this notch is not there, this outline here, right, of this little thingy. If that is the case, then when you obviously can only put it this way or this way, right? You're not gonna put it this way because obviously it doesn't match. So how do you know which way to put it? The sockets, when the protective cap is on, it can only go one way because we have those two notches over here. When it is installed, the socket AM5 and this number, all of this will read, as you can see, this is the orientation. The board is sitting in this orientation, right? That's how I resolder them. So you want to align it the way, or you want to put it the orientation as you read it, right? But if you don't have that, which also happens, then we have the pin number 1 over here, that little triangle, and all of these are round, right? And one is cut at the angle, and that is the corner that you wanna align with. Typically, you also have a little triangle over here, right? And that triangle aligns with this one. So that's your orientation. And that's pretty much it. The main advice that I could give you when it comes to aligning sockets is that it's a pain and at first, and you just need to fail a few times. One last note on that, because that's actually, I was thinking about it recently. Many of you guys send me some videos from other channels and some material, like what temperatures to use and stuff like that. Now, I didn't really look into that because at the moment I got the temperature relatively narrowed down to so I can get consistent results. But the reason I didn't want to start from that, like just copy someone else's numbers and see if they work, because I did want to fail many times, but not for the sake of failure, but for the sake of, how do you spot when the temperature is too high? What does it smell like when the socket is overheated? What does it smell like when the board is overheated? How does the board behave when it's overheated? How does it deform? How does it flex? What the board even feels like, because you can feel that on some boards when it has been overheated for too long, right? What do capacitors look like when they have been overheated, right? They change color a little bit. They change the shade a little bit. So all of that knowledge you wouldn't have if you just reproduce someone else's success. For that reason, I wanted to come up with my own numbers, with my own procedures, and obviously, like I can state enough how much help I got from you guys and how much time have you guys saved me in this endeavor. But again, I don't look for the ready procedure ready to be replicated, right? Because that I feel like I would definitely, objectively, I would miss a lot of the knowledge and experience that I gained by failing. So my best advice is, if you wanna do these repairs, just get a whole bunch of even broken boards off eBay and do it a few times, then a few dozen times. If it doesn't work, then just keep changing stuff so we can narrow it down. That's point number one. Point number two is that not every procedure, not every set of numbers that you will copy from someone else is going to work every time. In which case, you need that experience of multiple failures to just kind of adjust what you have, adjust your numbers to know whether you need to go up or down with the temperature. Maybe you need to increase the time, reduce time. There's few variations. In addition, the ambient temperature and the humidity and all that kind of stuff is going to affect this process. So again, if you have failed, if you've seen a lot of failures, if you conducted a lot of repairs that were failures, you're going to have invaluable experience that will allow you to not really rely on the numbers, because just like every board is different, every machine is slightly different. So say you narrowed down everything, replicated numbers on one machine, and now you have to switch to another machine, and suddenly you're lost. It doesn't work, and you don't know what to do with that, what to adjust, how to change it. So definitely, failure is the best advice that I can give you. Just fail a lot, especially after many failures. Once you succeed, that's gonna taste amazing. The taste of that victory, that first victory after a set of failures, is gonna have an amazing taste. So that's what I recommend. All right, let's get this socket soldered on and get this board off the bench, because we have a queue. Alright, the new socket is on, looks good, alignment, everything is good. Let's take a look. Now you may have noticed that first of all I didn't put the aluminum foil on the caps. No, I didn't mean to do that, I just forgot. I just plainly forgot. But they don't seem bulged. I didn't want to put it during the procedure because I figured let's see what's gonna happen, but you did probably notice that I did put the aluminum foil on this side, on the memory, because that is something that I was a little worried whether it would, you know, deform from the heat. It doesn't look like it. It's a little dirty still from the flux, but it looks alright. Now the only difference here was that first of all I put the heating element centered roughly somewhere here. This was the roughly the center, and since I can observe this side, and last time this side didn't get soldered on, and I cannot see it, I figured I'm just gonna be heating more on this side, and this one I can see over here. Now these sockets, when I was buying these on AliExpress, it said that the solder on them is leaded. They do look shiny, so maybe it is, but I would expect that at 225 the socket would have dropped, and at 235 it would be floating. But no, it did seem like at 225 it dropped a little, meaning that a little distance between the board and the socket definitely lowered, so they definitely softened up in 225, but it dropped at 235. So I'm not sure. They say it's leaded solder, but I'm not too convinced yet. And now, as you can see, some of the flux is not removed, and let's see the socket. I don't know if you can pick up on the discoloration, but there's discoloration. I mean, you can actually, because I did it yesterday, today I'm just analyzing it, and it looks like it changed. It's like evened out a bit. It looked more discolored. Or no, actually, yeah, it depends on the light. Yeah, you can really see it under the scope. So what I did yesterday, I ordered a ultrasonic cleaner, because I have two of them, but those little ones for the phone repair, basically for tiny boards. Maybe you can clean glasses in it too, but nothing beyond that. So I ordered a big 30-liter ultrasonic cleaner. It's 20 inches by roughly like 12 inches. So relatively big. It can accommodate the entire board. So we'll see what the ultrasonic cleaning will do to it, but I expect it's gonna be a nice clean socket and board as well. And so we'll test that next time, hopefully. Well, yeah, because I ordered it. It's from Georgia. It might be delivered tomorrow. So maybe not tomorrow, but the day after, maybe we'll do some analysis and check it out, see how it works. Now at this point, I have a track record of 4 boards that look like successful replacement. I don't have the confirmation, but as at least visually, alignment and the soldering looks good. So you're probably asking, why am I still not charging for this repair? So I figured I want to do at least 10 in the row, and out of those 10 in the row, I want to have 9 successful repairs. That will give me 90% success rate, which is enough for me to accept customer boards and charge for that. The other reason is that there is one repair shop from Massachusetts which offers this repair on eBay, and they charge $150, I think, with shipping. And on their listing, they don't mention anything about stripping the board from heat sinks and all that kind of stuff. So it seems to me a bit low. From the picture that I see, they use much more professional version of the device that I'm using. So that's probably much easier for them. I'm not sure how they align the socket, but well, they don't publish the videos of their repairs and replacements. But maybe that's why they offer it for this little. So far, it looks like they sold four repairs. I don't know when. I didn't check the customer feedback on those, so I don't know. But it looks legit. But 150. It's actually $149 if I remember correctly. That seems a bit low, but my point is that my price would have to be below $200, and it makes sense for some boards, especially some of these boards are worth like close to $1,000, at least those really high-end boards. Others, to get even decent board, you gotta cough up $500, but for the new one. So if you buy such board with only busted socket for $20, well, no one's gonna sell you a board like that for $20. At least not on eBay. The prices on eBay for malfunctioning and basically damaged stuff are crazy. The board is worth $500, so they're gonna sell you broken one for $120, and yeah, go make profit on that. In my book, anything that's broken, that's like 10% of the value, right? So if it's $500 board, if it's broken, that's a $50 board, and that's a fair price in my book. You get rid of the junk, and someone stands to make some profit. Otherwise, each board you can probably sell for $20-30 each board on the just for a gold. What do you call it? The retrieving, recycling, basically for recycling gold, and there's probably some platinum, some other metals that are worth something. I don't remember. Back in the day, it was around, and that was way back in the day, so obviously the value of the dollar has changed a lot since then, but it was roughly $5 per board, but it doesn't matter what kind of board, right? And the other ones would charge per, it was somewhere around $30 per kilo, and each board was like quarter of a kilogram, 250 grams per board. So you get like $30 for 4 boards, something like that. But basically, that is my idea at the moment. So this is board number 4. So I got 6 more to go. So if you have board with the busted socket, send it in, and it costs you next to nothing other than the shipping. But just please remove all the heat sinks and everything. Send it like this. Don't make me remove those. This one actually was pretty decent regarding the heat sinks, meaning not a lot of them and no back plate, so that's easier. But this is pretty much it. So one thing that I forgot to mention, actually, that might be of importance to you. I have a hygrometer which is the ANEG multimeter that we reviewed some time ago, and it shows me the humidity other than the temperature, right? And as you can see, the humidity right now is 31%. Yesterday it was at 24. Typically, I like to do it when this meter shows LL, which means that there's not enough moisture in the air to even measure the humidity. So it's not zero, but it's close to zero enough that this meter cannot even determine how much moisture is in the air. And that's how I like to keep my shop when I do this. Yesterday it was high humidity. It was really rainy, misty, foggy. So what I did, and you can see that on the footage, I started with what was it, 45 degrees, and I kept it for a few cycles. Then I up to 60 degrees, kept it for another couple cycles, and then I slowly started upping the temperature. That is my advice. I haven't had issues with it yet, but I was advised that there is a certain phenomenon that is referred to as a popcorning of the board. If there's enough moisture in the board and you heat it up quickly, then that moisture is gonna try to escape quickly, and the water, obviously, when heated, expands, and especially as a steam, right? That's how the steam engines work. So just for that, I decided to heat it up slowly, and just basically to dry the board first. Not only the board, but also the whole shop. So that is definitely a good thing to do prophylactically if you're dealing with high humidity. And I'm in Georgia, so humidity is usually pretty high over here. Not terribly high, but it's relatively humid. If you're in more humid places, definitely this is probably not the repair that you want to do because of that. And especially if you receive the board and it's cold outside and it's been exposed to cold, then probably it's a good procedure to have to just keep the board in the shop in the dry area for a day or two before you perform this repair, because we do have to heat it up. Another thing that I actually picked it up from a some random YouTube video of taking I don't have anything like that over here, but basically taking something like that, and after you remove the socket, just scrape it quickly, you know, the solder when it's hot, because I was doing that with the soldering iron, but then from that video I noticed that, well, yeah, you don't need a soldering iron to do it. You can do it with some piece of steel or something. So that's what I'm going to try next time. That's going to save a lot of time. And not only that, because it's not only about saving time, it's also if I can do it in one cycle, that would be great. Meaning, I heat it up, I remove the socket, I quickly remove the solder, clean it up, put some flux, put the new socket on, and blast it with the temperature. That way, I heat up or preheat the board only once, right? My current procedure usually requires 2 cycles. First for removal and cleaning, and then reheating it again, or cooling it down, and then reheating it again to replace the socket. So if I can do it in one cycle, that first of all saves some time, and second of all reduces the damage to the board due to overheat or due to heating. And someone told me that these boards can only take like 3 heating cycles, so you can heat them up and cool them down just 3 times before there's some damage. I don't know that to be true, but I don't have any reasons not to believe whoever gave me that advice. So I'm gonna try to minimize the number of heating cycles. And that is it. Hope you enjoyed that. Thank you very much for watching. I do appreciate you. And I shall see you in the next one.